Here we are with section 3.4 exercises number 36 for the following function, modeling growth of an investment account with 8% interest, compounded monthly. Fill out the table. Now we'll notice that 8% shows up right here. This is the compounding interest formula. 8% and it compounds monthly. That means 12 times per year. So the interest gets cut in twelfths for each month, but then gets compounded 12 times as often. All right, so we're going to fill out the table, and the variable x represents the number of years that the account has been growing. And this is a function, so we're just going to stick these numbers in right here. 0 goes in here. Now, that's kind of nice. We don't even need a calculator for that. For 0, anything to the 0 power is 1. So this first level is just 2,000. That's the first A of 0 is 2,000. Now when we stick a 2 in here, we're going to get, well, we better punch this out on the calculator. 2,000 times 1 plus 0.08 divided by 12, and then all to the 12 times 2. So we put the 2 right where that x goes in. So that is a 24 that we're going to put in there. Let's go ahead and put the parentheses and 12 times 2. You can see that. And we get 2345.76. 2345.76. That's how much money you would have in the account after 2 years. Now let's stick in 5, and we can use this great capability of a TI-85 to just we hit entry, second entry, and it went to the previous entry, and now we've got the whole thing. Now we're just replacing that value with a 5. Enter. And this is 2979.69. 2979.69. There we go. And notice it's growing, and it's growing by greater margin each time. Okay, so now let's do a 10. And replace that guy right there with a 10, and then close the parentheses and enter 4439.28. 4439.28. 15. Type in the whole thing again, but this time with a 15 there, and we get 6613.84. 6613.84. I'm leaving 2 decimal places because we're talking about an investment with money, so this would be dollars and cents. But it's not totally necessary given this part of the problem. All right, next one. Let's run 25 in there. Second entry, and then type the whole thing in, this time with a 25 at the end. 14,680.35. 14,680.35 cents. And then finally, after 35 years, so this ought to be pretty big by the time it's allowed to go for 35 years, put a 35 right there and enter 32,585, 32,585.10. Excellent, and that's what it looks like. Now, it says to graph it or sketch a graph of it, so it's a nice idea to have all the x's that we're going to go. So right here, we're going to be out, here's going to be like 35,000. So we have to, wait a second, not on the x-axis, what are you doing? We're going up to a bunch of like 35 years. And then on the y-axis, we're going to be up at around 35,000. So we've really zoomed out on the y-axis. So let's put these guys in. 0 is about 2,000. So if that's 30, there's about 15, 10. So we're about right here at 2,000. So that's at 0. And so let's do this 5, 10, 15, 20, 25, 30, 35 there. So at 2 years, we're just a little bit higher. At 5 years, we're up a little bit higher. At 10 years, we're up almost double of what we were before, or more than double. 15 years, we're like triple. We skipped 20. 25 years, we're up at like 14,000. We're about halfway, and then that one's clear up here I like 32,000. And you can see this is kind of taking on, it's a curve. It's growing ever so slowly, but it's getting steeper and steeper as it moves on. And that is exponential growth. All right, that's what it looks like.